Okay, Sarah, this episode, oh my lands, you talking about huge.
Do you know a zettabyte?
I had not heard of a zettabyte
I've heard of
until we
gigabytes
started.
and terabytes. This is way beyond that. We're talking data visualization, all things data visualization with Vetria Byrd.
Yeah, I can't decide what my favorite thing she said was. When she said a picture, they say a picture can tell 1,000 words, but a data visualization can be 1,000,000,000 points.
Yes.
I'm like, yeah, that's it. When she talks about your visualization as a story, what is your objectives, your goal? You got to think about your audience and not overwhelming. And it's all the insights she gave. And
I'm much more basic. I'm just, your pie graph needs to add up to 100%. Right.
Yeah, well, she did say that. Yes, we talked about the what was it? It was a V,
veracity of data.
Veracity of data. One of the 4 V's of data she talked about. There is a lot of really, really good information that she explained to us and she went over. Some of this, I got to say, was brand new for me. I had not heard of these particular aspects, but data visualization, something very important that really it goes across the board. And this is a really good one for people to listen to help you in
just
your data visualization.
Day-to-day understanding of data and our understandings. I learned that where I'm at right now with data understanding and data visualization is at the very entry level, and there's way further to go.
The foundations, those are awesome graphics. If you're able to see the YouTube one for it's outstanding. We really love that. We did our best explaining the graphics. I mean, she's data visualization. She's going to have rocking graphics. We did the best we could to explain graphics for our audio audience. Listeners. And so we did our best with that. Some of those we obviously didn't do justice, and we apologize for that. But this will be a really good one. Enjoy it.
Joining us today on Superheroes of Science, we are so pleased to welcome Vetria Byrd. Vetria is the Assistant Professor of Computer Graphics Technology with Purdue Polytechnic Institute and Director of the Byrd Data Visualization Lab. So welcome.
Good afternoon, and thank you so much for giving me this opportunity to talk to you today about data visualization. That is the field and the area in which I teach at the Polytechnic Institute. So I teach a number of classes that I have developed to introduce data visualization to undergraduates, but I'm also interested in introducing data visualization to anyone that is interested in the field, because it is such an important field because we are exposed to data at all times. And so one of the things that I like to do is to kind of give you a brief introduction to data visualization, and then to answer any questions that you might have about data visualization. So one thing that I want to say or to point out is that data visualization is a process, and it is a process of transforming raw complex data into a visual representation of what that data represents that does not overwhelm the viewer.
I like that part.
Yes. Well, and one of the things I'm interested in too is a holistic approach to data visualization. So when you think about all of the data that we encounter on a daily basis, I like to take a holistic approach. So sometimes people will say, well, data visualization is a skill, or they may ask, well, is it a tool? And my answer is yes. It's all of those things, both of those things, because there are elements of each one of those parts in data visualization. So in terms of a skill, it's data and information fundamentals, but basically it's telling a story. Telling a story. If you think about, when we were growing up and we read books and you can visualize what's happening as people are telling the story, that's what data visualization is. And it's actually understanding that life cycle that data goes through that allows you to make sense of that data. And so there are different visualization tools that are out there that can be used that will help with understanding the data visualization process.
Well, I love the telling a story part of this. Yeah, this is seems like something that we could all do.
Yes, absolutely. And when, again, when you think about what has happened in the last year or so, where data was everywhere and people wanted to know more and more about what was going on with the COVID-19 virus, and data visualization was one of those things, one of those tools that helped to convey what was going on, not only to the medical field, but to the common person. And you've heard the phrase, a picture is worth 1,000 words. And in this case, in many cases, a picture is worth thousands, millions, billions of data points, because that's what we're actually dealing with. And so what data visualization does is that it makes it understandable for everyone, not just for the scientists, not just for the academic person, but for anyone who, can look at a picture and hopefully gain some insight from what that data represents. So I teach a number of courses at Purdue, and basically for undergraduates and graduate students as well. I am also the faculty lead for the campus-wide DataMine Data Visualization Living Learning Community. That's a mouthful. So what I do is I work with students from all over campus who are interested in data visualization, and I help them to understand the basic elements of what data is, and also how to transform that data into actual insight. And so again, my favorite slide and things that I share with my students all the time is that the purpose of visualization is insight, not pictures. Because oftentimes people will think, if I could create a picture, I'm good. I know it all. Not so much. It's the things that happen with the data behind the scenes that actually help to provide insight, as opposed to just making a pretty picture. So there's more to it than a pretty picture. I like to think that the pretty picture is the icing on the cake. Actually understanding that data, that's the process of visualizing data and making sense of it.
And I think too, especially for students, and I'm so glad that what you're doing, because I think having taught students, when they collect data, especially if it's from a research question that maybe they've just thought of and they really don't know what those data points might be, sometimes that data can be really confusing to even begin to know, like, what type of, do I put it in a graph? What kind of thing do I do to make sense of it?
Exactly. That's a very good point. And one of the things that I try to do in my classes is we talk about different types of graphs. Everyone's familiar with the pie chart and the line graph, but there are so many options and so many ways to visualize data, depending upon what the data looks like. And so what data visualization does, it gives them a different perspective of that data. Like you just mentioned, you collect data, and typically it's in maybe a spreadsheet or a table, but how can you represent that for those of us, myself included, who prefer to look at a visual as opposed to rows and rows of numbers or words? How can I visually show that, or show the relationships that exist in that data in a more appealing way, but still, is true to the nature of the data itself? So you're absolutely right. Helping students to understand and to visually represent data that they collect, I think that will help them to appreciate the value and the benefits of visualization as well.
Well, is there a program? I'm sorry if we're interrupting your flow. Is there a program or a type of way to visualize data that you would recommend for someone, whether it's a student who hadn't done a lot, or it's just somebody who has data that wants to show other people to help convince their story or whatnot? Are there some programs that you're like, hey, yeah, these are really good starter programs?
So that is a very good question. And so I will say that there is no silver bullet. So, there's a lot of different types of data out there, and the data actually dictates the type of tool that you will use. So I will say students tend to find Power BI to be very useful, and they use it whenever they have an opportunity to. I think mostly because it is very intuitive and easy to learn. There are some other programs that have a little bit more functionality, a little bit more powerful, but of course, there's a longer startup period or learning curve. One of the tools that I use in my class is Tableau. And one of the reasons why I use Tableau, it's very user friendly. They have what's called a show me button. So if students can figure out how to get the data into Tableau and they just don't know what type of graph to use, guess what? There's a little button that says, show me. And if you click on it, it will show you all different types of visualizations that you can create based on the type of data that you've uploaded. So if, for example, you have a table of figures or numbers that you think you want to do, for example, a geographic type of visualization, but you don't have geo coordinates, Tableau will say, sorry, you need these types of data in order to create that type of visualization. So there are also things like Google Charts. They have some tools that can be used in a fairly easy manner. And it really just depends on the types of visualizations and the type of data that you have that will determine the type of tool that you will use.
Okay. Yeah, I do too. That's really, I didn't know about Google Charts, so that's interesting. I'll have to check that one out.
And it's very easy to use. It is accessible, which is also good, you know, for students. They want to be able to have access to these things. And so it's helpful to have some type of tools that you can use quickly, as opposed to some that require, like I said, a longer learning curve to learn. But the more robust the tool, the more different types of charts and things that you can use it for.
I see.
And I can send you a list of resources with some particular tools, starting tools, if you'd like.
That'd be outstanding.
Awesome.
That might be helpful, and some things that I typically recommend for the novice visualizer.
Perfect.
So one of the things I would like to point out is that, yes, the purpose of visualization is insight, not pictures, but how do we go from data to insight? And so this is a chart that I use in my class often because I think that it shows that progression. And so you start with data. And so data is basically information. And so what we try to do is we look at the different types of patterns that exist, things that you can't see unaided by data visualization tools. And so what this allows us to look at the patterns, to see if there are relationships that exist, things that you don't necessarily see. And that way you're looking at the who, the what, the where, and when. So at the very basic level, when you're getting all this information in or getting this data in, we want to look at the relationships that exist in that data. Once you understand the relationships that exist, we want to look at those patterns, and those patterns allow us to take a look at how is this done? So what is the purpose? What is the meaning of what we're seeing? And that leads to knowledge. Once we have that knowledge, then we're able to synthesize new knowledge from the data or the information that you gained or that you've uncovered. And so this understanding allows us to take it the next step to actually start analyzing. And ultimately what we want to do is to look at those principles that exist that leads to wisdom, that insight. How do we take that knowledge and make some predictions or some recommendations based on the information and the data that we've been working with? And so just seeing this progression sometimes, you know, turns on a light bulb for some people to say, okay, I can see this natural progression or process that we go from data to looking at the relevance of what we have and also making sense of those relationships that exist in the data.
Now, would these be individual I'm guessing it would change, my guess, but would this be something that we would try to have all of this within one visualization? Or would we have multiple visualizations showing different ones? Like I might have one for knowledge, one for understanding.
A great question. I think it really depends on what the purpose and the goal is for the visualization that you're creating. And the other thing that's very important, who is your audience? So depending on who the audience is, that's going to tell you the level of detail that you will need to have in the visualization that you created. I love the fact that you asked the question about having multiple visualizations, because oftentimes students feel, I only need one that will tell, I have this big story to tell, so I'm going to create this huge or this one visualization that's going to tell everything. You don't want to overwhelm. And so when you look at or you create the visualizations, it may be necessary to create multiple ones that work together so that you don't overwhelm and confuse the viewer or yourself, because sometimes it can be so big. And I've actually worked on some projects where the person would say, I just want one visualization. Here's all my data. Just give me one big visualization. I think you're defeating the purpose of visualization, because and you may have seen them on the net, on the internet, where it can be so complex that it doesn't really make any sense. And so in those cases, you are not gaining any insight. You're actually complicating things. And so depending on one, who your audience is and what you're trying to convey, that will determine one, the type of visualization or the chart layouts that you'll use, and also how many visualizations that you need to actually convey the point that you're trying to make. So I think it really depends on the problem and the questions that you're trying to answer, which will dictate how many visualizations and the content that you contain in each one, if that makes sense.
Yes. Yeah.
So one thing that I like to do, or what I've done, is I'm focusing on what I call building data visualization capacity. And what I've done is I've identified 4 levels of student engagement and participation that I have observed in teaching and developing data visualization courses. And so I think that we all start at that lower level, which is the understanding, the learner level. That's understanding data, understanding the role of data, understanding how it impacts and the role that it plays in the data visualization process. That also falls under the heading of data literacy, visual literacy, and these are maybe some terms that you've heard before, in which you're really basically understanding those fundamental concepts that are needed to understand the role that data plays in everything that we do. Once you have that understanding, I feel that then you can better understand the data visualization process, which is at that second level, which is the application level. So at that point, you're a user. And what does the user do? They use visualization tools. They use different types of layouts. They use different types of applications. And so this is where that data visualization process, I feel, would come into play. Now, I've listed 4 levels here, and so I've learned, I've identified these levels, but I also realized not everyone wants to go all the way up to the top here and to write actual code to do data visualization. But what this does is it shows a progressive learning path. So some people will say, you know, I just need to have a better understanding of what this thing called data visualization is. And I need to have a level of understanding that will allow me to be able to use data visualization applications. And that may be as far as they would want to go. But because we have so much data, data is everywhere. I like to say resistance is futile. If you're a science fiction person, you've heard that before, because data is all around us. And so some people may want to go that extra step, which would be the analysis stage. So after you've been able, or you understand the process of data visualization and you're comfortable actually creating visualizations using different applications, that next step is for gaining insight is the analysis phase. So how do I analyze this data that I'm using? More specifically, how can I use data visualization to help facilitate that analysis? And then at the very top level, for those who are, interested in actually developing data visualization environments, I consider that to be the top level of development, where you're actually writing code to create the applications that we use in that third level. And so this kind of summarizes the things that occur or the skill sets at each of these levels, but it also provides a progressive learning path, which is one of the things that is not present in the current literature on how do we go from learner to actual developer or actual analysis. And so I think that this would help for those who are interested in seeing what those next steps could be.
I really, really like how you have this designed as a foundations, because really to efficiently use or be a user of an application, to really understanding the visual literacy, the information literacy, the data fluency, and the data literacy are just important pillars of that understanding. And I love that you've put those in there. And a lot of times, visual literacy, I think, is one of them that it seems like the students, they don't get there.
Right.
They don't understand that. They haven't quite got to that point where they can transform that into information literacy. And so I think that's a very key thing that I really appreciate seeing.
I think just seeing how you have this graphic laid out, and I've heard a lot about, you know, data literacy and data fluency, and thinking, oh, well, when I'm data fluent, that will be great because then I can do, and I'm thinking, wow, no, that's a foundational skill. That's going to allow me to get to these next levels. But then also I'm thinking as a teacher, this takes a lot of practice to, you know, we practice a lot with, you know, reading directions, and maybe we get some data, and maybe we get enough data to get a graph out of that. But to me, that's even lower than that. Like that's like way before we get to these foundations. This would take a lot of practice with a lot of different types of data to get to be able to build up from here.
And that's the key, different types of data. And for students, you know, sometimes they think, okay, I understand this type of data. For example, one of the examples that I like to share with them, email could be a type of data. Zip codes could be a type of data. So what does data look like? And so the understanding is, what is important to understand is that it is a process, and that, again, there's no silver bullet, which means that data is evolving every day, the different types of data that we get. You know, if you have a Fitbit, guess what? There's data being collected. If you go to the store and you purchase something, that transaction, that is data. If you watch the weather, which we all do, we want to know what's happening outside, that's data. And so being able to understand that there are different types of data, there are different types of tools and techniques to be used for different types of data. That's one of the key elements that I think is essential that students learn, and basically anyone with an interest in data visualization, because that having that basic understanding will allow you to approach even more complex problems as you get that experience. So one of the things that we do in the classes that I teach is that we get hands-on experience. So one of the things I love to do is I will give them in the beginning, because I want them to focus more so on understanding the process, a data set that is what I'm going to call clean, nice, neat, everything's in order, there's nothing missing, it's just perfect. Unfortunately, students come to think, oh, that's the way data is. And I have to enlighten them and say, no, you know, 80 to 90% of the process of visualizing data is the pre-processing, getting it into a format that it needs to be in so that you can do some further analysis or further visual representations of that data. So understanding that process, understanding that your first visualization will not be your last. Very important. And the first visualization tool that you learn to master or you're comfortable with will not be your last visualization tool, because as data evolves, so do different types of visualization tools that you will use. So those are very good points that you've made.
Wow.
I like that.
Yeah.
I like that. It reminds me of Bloom's taxonomy of higher order.
It does.
Higher level thinking. Yeah, she has it all right there.
Right.
But this is like the modern day.
Absolutely.
This is what is today's updated. I love it.
And in fact, I'm glad that you mentioned Bloom's taxonomy, because that is one of the taxonomies that I use for introducing the data visualization process, because it shows you from lower order thinking up to higher order thinking as you progress through the data visualization process. And so one of the things, or I've mentioned Insight before, Insight allows us to do a lot of different things. In addition to telling a story, it also allows us to make decisions. It allows for discovery, analysis of data, and it also allows us to explain more complex data in a very simplistic way so that it broadens the applicability of data visualization and the data that is being looked at, depending upon what problem it is that you're trying to address. So I really like this particular visualization because it kind of shows you how they're all connected and how Insight really sits at the intersection of all of these things.
Yeah, I do too.
I guess we shouldn't have been surprised that she would have good visualization.
I know, right?
Well, no
Well,
visualization talk is complete without visuals.
and I think really in these discussions, it's just kind of hitting me as you're speaking how much just art in general is sort of playing into that. And I wouldn't have just thought of this naturally, but there's
Absolutely. Yeah. So data comes in all different shapes and forms, even in some respects that you don't even think about. And so what I want to do is to talk a little bit about those elements that I mentioned before, just to kind of give you a little bit more detail on each one of these aspects that insight allows us to do. So it allows us to spot differences. And so here's a little quiz. How many differences do you see between the figure at the top and the figure at the bottom?
7.
uh,
I'm at 7.
I'm at 4.
Okay, so
5.
there we go. And so this is what we have. We have color, we have these three-dimensional action figures that are there. And I'm not sure if you saw all of the differences, but it took a little bit, to try to look at what's at the top picture and what's in
But
the bottom.
you're missing one.
Exactly. So which one am I missing?
The flag.
The flag, absolutely. So you caught it. And so that's one of the things that I do for students as well. I will point out the ones that I've circled, but then also to see if you're paying attention. So you're absolutely right. So yes, the flag, those little lines there on the flag. So that took a little bit of effort, to compare, because like I said, we have these things like color, but what if we remove the color?
Oh,
Yeah, a little bit more challenging to
Yes,
figure
okay.
to figure out where the differences are. And so I'm just going to go ahead forward
Yeah.
to point these out. So these are where the differences are. And so one of the things that this shows is that when you take away some elements that actually help you to figure out those differences. In the case of the previous one, we had color to help here. When you remove the color, everything is like it's just black and white. So it makes it a little bit more challenging to point those differences.
Absolutely.
What happened if you have numbers? So hopefully you can see a trend here. It's getting more and more complicated
Yes, it is.
as we move forward in terms of trying to spot those differences. And one of the things that complicates this particular example is that sometimes the ones look like the sevens, or the sevens look like the ones.
I found 8, but I don't know.
There are the sevens. I think there are 10, maybe.
Yeah,
I believe they're 10.
Yeah, I missed it.
And so again, it's much difficult to see once we get into what's called machine language. So the machine can pick these out very quickly because, we can write a program to say, identify a 1 versus a 7. But when we're looking at it with the human eye, it's a little bit more difficult. And so there are some things that we could do in data visualization to help things stand out. And you've seen these even in these couple of slides that I've shown. You can add color. You can bold things, you can change the perception of things, the orientation of things to help you in spotting those differences. But as data continues to grow, looking at numbers and zeros and ones, it becomes a challenge. And so what data visualization does, one of the things, it allows us to make these discoveries, to pick out those differences in data that exists. And so it also helps us to make decisions. If you recall the Human Genome Project, when it first started, there was so much data that they didn't know what to do with. And so data visualization was one of the tools that allowed them to look at that data in a more insightful way and to ask questions or answer questions that they didn't even know existed yet. That allows for you to explore different things. So if you have a large data set that you don't really know what to do with, data visualization is an option that will help you to make more sense out of it. It also leads to analysis of data. So one of the things that I'm seeing, even in the movie industry, is that, believe it or not, they now have visualization scientists on there as a part of their crew or their teams. I like to sit and watch the credits as they roll by. That's the nerdy side of me. And to my surprise, in these movies that I have here on this particular slide, they literally have visualization scientist. So if I go and I see a movie that has that in the credits, I'll go back to my class and I'll say, listen, would you like some extra points? Go watch this movie and see if you see data visualization
There you go.
scientists and the role that data visualization plays in the different types of movies that we see as well.
Yeah.
And so, you know, the applications of visualization are many. We have BioViz that looks at biological types of data, which is basically, you know, computer animation. And coincidentally, the gaming industry actually benefits, or there's a mutual beneficiary relationship between the gaming industry and data visualization, because the gamers, they want realistic data, realistic visuals, which, you know, in science, we can benefit from that.
Yes. Oh.
All types of data that we see every day or we hear of, if you tweet or if you're on social media, that's all different types of data that's being collected there and used for different purposes and usage. There's something called geographic visualization, which is a very prominent field now, where if you own a GPS or if you use any type of tracking device for maybe tracking your steps, which I like to see or to use as I'm getting my exercise, there's a Fitbit app that will actually map your steps as you walk. And so it's interesting to see the visualization at the end of the day that I've created just my steps. And so it's always just fun to see how these things can be utilized in our daily practice. And then, of course, there's scientific visualization. So if you look up data visualization, most likely scientific visualization will be the first thing that comes up in a Google search, because it was through scientific visualization that we actually started using data visualization, and it's become more prevalent in these other areas that I've shown in the previous slides. So it allows us to convert, you know, raw data into a data that is understandable to humans. For example, this is a sample data set. Would you believe that this is a sample data set that represents this?
Oh,
Amazing to see.
bunch of numbers turned into a very interesting.
So I think it says density.
Well, it's a rocket with the rocket boosters on the bottom. So if you see the space shuttle, it's like a space shuttle here,
Yeah.
and then the rocket boosters underneath. And then it also shows you weather patterns, or the way that the weather travels around, wind travels around these particular objects.
That's what you were seeing as lines.
Yeah, lots of ways in which data visualization can be utilized. So now I will continue forward until you have questions.
Well, I guess I just have a question. So if we're learning about data visualization, and I know sometimes this would come up and it would be totally innocent, like students wouldn't necessarily know that they were creating graphs that might be misleading. But I feel like this is something that if we don't know what we don't know, and we're looking at that, we're taking a lot for granted. Sometimes just viewing the graphs or the pictures or whatever that people are showing us. Do you have any tips for your average viewer to just be wary, or is that something that we should even consider, like
Absolutely.
forcing? I don't know how to ask the question.
No, that is a very good point, because one of the things that I do in the class is not only teach students how to create those visualizations, and then once I'm fairly convinced that they understand that process, then we get into, you know, how to not lie with data visualizations. And so
How to not lie.
How to not lie. It's kind of like, you know, how not to lie with statistics or something like that. But
yeah.
you know, it's very easy to do, and sometimes it's done unknowingly. For example, there's a whole presentation that I could give on the different types of things, what not to do. But some basic things is 3-dimensional visualizations. A lot of people think, oh, I can put it in 3D. It looks really nice and really cool with what you're looking at. But does it obstruct any of the parts of visualization when you create those three-dimensional, let's say, bar graphs? And that's one of the challenges. And what I'll do is I'll send you guys some of these, because I don't have it in the presentation right now, but I'll send these to you if that will help for the editing. But pie charts are another thing. oftentimes what you should do is you should minimize the number of elements that you are representing in a pie chart. I would like to say keep it to no more than 4, 5 at the most. And the reason for that is once you get these really, really tiny small slices that you really can't see, or maybe you have more than 4, let's say you have 10, it's really hard to see how big of that slice of the pie that is actually represented accurately in your visualization. Also with the pie chart, make sure it totals 100%. That's a big issue with students. Oftentimes you'll see that the numbers just don't add up. And so just some basic things, you know, you're creating this visualization. It looks really nice and really pretty. You want to make sure that those numbers add up. Another thing for just some basic tips, color. You want to, if you're using color, you want to be aware of some people have color, I'm going to call sensitivities, or maybe, you know, cannot see different colors placed together. And so you want to use a color palette that everyone, including those who maybe have some color blindness, can also see the different types of representation that you have there. Another way around that is to use patterns. And so although color is often the go-to as to how to create, or when you're creating visualizations, sometimes you can use different patterns for different parts of the visualization. And so that will also help the students or whomever is viewing the visualization to understand and get the insight that is intended for that visualization. So color and perception, color, different colors also is one of the things, basic best practices for data visualization. Labeling your axes. Sometimes we will have a visualization and you think, oh, it's obvious. Everybody knows that. Don't assume. You still want to make sure that you label the axes and you label them correctly. The other thing is, and we touched on this a little bit before, try not to put everything into one visualization. It's okay to have more than one. I think that's a bigger issue because again, you'll get some visualizations that are very crowded or too busy. You can have too much going on that it obstructs, you know, the purpose that you're trying to convey there.
That whole overwhelmed thing that you mentioned at first. Yeah, I see a lot of visualizations that just kind of overwhelm me mentally, and I'm not sure what the whole message really is there.
Exactly. And if it's too busy, guess what? You stop paying attention instantly. You're moving on to the next to the next thing. So you want it. Sometimes simplicity is best, you know. And so the other thing to do is to get a fresh eye. Ask a friend, what do you see? What does this visualization tell you? And that's one of the things that we do in the class. I'll have students to create visualizations, and then we do what's called a critique, which means that you have to share your visualization with someone who has no idea what you're working on, but your visualization is supposed to stand on its own. So if I give you a visualization and I say, what does this mean? What are you getting from this? And one or two things could happen. One, they could come back and give you the insights that you had anticipated, or, which often happens, they come with a different perspective. And they may say, well, did you think about this? Or did you think about that? And so the whole process of visualization, it is an iterative process. Because you remember I said your first visualization will not be your last. Because once you get that feedback, the expectation is that you will take that feedback into consideration, and hopefully that will help you to refine it so that it does convey what you are intending for it to convey.
Yeah. All of that. That's excellent. I love all of those.
All of that.
Yes. Excellent.
So one of the things that I talk with students and oftentimes some parents as well is, why should you care about data visualization? Again, like I said, data is everywhere. And this particular slide is actually dated because we have even more data, types of data, but it gives you an idea of how fast data is growing, the size of data. So not only do we have to think about the data itself, we have to think about, where am I going to store this information? You know, because you've heard of big data. Sometimes we get data that we just cannot handle on, say, a laptop. And so that could lead to some high performance computing resources that may be needed. And so when you think about people that tweet and people that, use all these different types of devices, our cars are networked and it's generating data. There is a need and a demand for people with these skill sets. And even just at a basic daily usage, daily practice, we encounter so many different types of data on a daily basis that we're having to process it individually. But hopefully what you can see in this particular slide is that it shows you how the growth of data is changing the face in how we approach, how we look at data going forward.
And I'm seeing some prefixes here that I've never seen ever. I see gigabytes, but then I see that looks like zettabytes.
Zettabytes, yeah,
And yottabytes.
Yeah, I think that's kind of just a play on words on that one. But
Okay.
over here, I think, it's kind of to think of you're getting to like this Zen state where, data is just becoming such a common part of what we do, what we see. But also, as you said, you start down here with kilobytes and then megabytes and then gigabytes. And then it gets to a point where it's just mind-boggling. And so when we get to that point, in order to make sense of it, that's where data visualization comes into play to help us to maybe look at a small section of the data to make some sense of that and then see how it scales. And so being able to understand the process of data visualization, the value and what it brings to just problem solving and just understanding just the different things that we see each day is phenomenal. And so I think every person should have some basic visualization skills, because when you look at, even for those of us, when you get a bill these days, they show you the usage, how much water have you used over the course of a year, or your, what do they call it? Your credit score.
Yes.
They show you the little, graph of where you are, where you might want to be. And so the possibilities are endless as to the role and where data comes into play.
Are we going to hit in like a stop? I mean, it just seems like it's growing exponentially. There's just more and more. Will we ever get to a point where it's like, this is the max data we'll ever produce, or is it just infinite? We'll just keep going.
Stop the data.
I was about to say, I think it's going to continue to grow because we're evolving in the sense of what data looks like. And so as long as there are discoveries to be made, there's different ways of representing different things, streaming of data, different types of data, I don't foresee a plateau anytime soon, mainly because of the different types of data that's being generated, the way it's being used in different ways that have been used differently now than it was in the past. And so if you look at the evolution of how data has been transformed and is being used now, and things are constantly changing, I think the answer to your question is, if there is a plateau, I don't see it happening anytime soon.
We're getting more types of data every day. I don't see
Yeah.
how it could plateau. I remember when a 1 gigabyte hard drive seemed absolutely insurmountable.
Right.
Like you would never fill that. And now it's like,
Well,
my personal computer has an 8 terabyte hard drive.
well, but it wasn't that long ago, and now we're already like
Correct.
you're saying terabyte capacity. I guess maybe at what point are we going to reach the limit of what we can process? Or
I think that's where technology is keeping
exactly. Yeah, and those high performance computing resources, that's where they come into play when our physical abilities are maxed out. We're taking in as much as we can comprehend and process. That's when we have those high performance computing resources that will allow us to do these high resolution images and visualizations that will allow you to zoom in on maybe the tip of a pen to do all kinds of amazing things. And so just being able to look at and understanding the process, that's where data visualization, I think, is most beneficial.
It is mind numbing.
It really
It
like,
blows your mind.
Yes.
yeah.
And it's just the tip of the iceberg, just the things that I've discussed today. I think this image really says it all. It's that this is what we know on the top, and what's underneath is the rest. And so that's the area where big data comes into play.
Wow.
I like that.
I do too.
I like that. Yeah, I love the visuals.
Oh my goodness.
Yes. So I want to touch on 4 V's of big data.
Oh,
And so there may be more, but these are some that really kind of sum up the different aspects. And basically, it's a nice transition from what we've just been talking about on that previous slides. Data is everywhere. Where is it coming from? There's so many different types of data visualization or data. We look at the volume, which is the scale of data. So on the previous slide, I also talked about zettabytes. And if you look at how many billions of people there are and how many cell phones there are and data plans, all those types of things, we really have to start looking at the volume or the scale of data and how to actually represent it and how to actually deal with it. The next thing is velocity. And we're really seeing this with the Internet of Things, streaming of data, videos, movies, sensors in cars, the different types of networks that exist. And so velocity is another element of data that has to be taken into consideration as well. We've talked about this a lot, different types of data, different forms of data. It can be in a table form. It can be, like I said, Fitbits or movies, tweets, social media, Facebook, you name it. It's endless in the different types of data that we're encountering. And actually, different types of formats that are being created in the scientific world, but also in daily practice as well. And then lastly, the veracity of data. And so we maybe touched on this kind of, sort of. So when we create visualizations, we also want to, as I mentioned before, not intentionally lie in our visualizations. And so we also want to look at the uncertainty of data. So what does that mean? So when we look at the weather, a lot of that data is uncertain because weather, as you know, can change instantly. And so one of the things that you want to look at is how do we look at what's called veracity of the data as well. So we want to be true to the nature of the data. We want to look at, the uncertainty of the data. How do we deal with that? And how do we represent it? So this is an open field right now, and lots of research is being done in this area. But these are, I think there's a slide that shows all 4 of them together. This the big 4 V's of big data. And there may be more, but this kind of summarizes it, I think, kind of brings it together for those who are interested and have questions about the ways in which the roles that data plays in data visualization.
I like that.
Yeah.
I like that. Especially the veracity.
Yes.
Talk about uncertainty of data. That's a big one we talk to students about.
And keep in mind, each one of these 4 elements is worthy of a lecture individually on their own.
Right. Yes.
And so over the course of introducing data visualization to students, we talk about each one of these elements and help the students to start thinking about them, thinking about data and visualization in different ways, so that it helps them to have a different perspective, as opposed to just saying, okay, I create a visualization, I'm done, I understand this process. However, what's the interesting part is, can you articulate the relationships that exist in the data behind the visualization? So what I found is that students can create, and I tell students, I am confident that you can create a bar chart or a line graph. What I want to know is, do you understand the data behind the graph or behind the visualization? And so that is a key element that is important for students to know, and for those who are dealing with data, regardless of the format, is understanding those relationships that exist in that data.
Like that. Let's go back to our visualization activity.
Yeah.
We have activities showing different graphs, and students have to match the graphs with
Mm-hmm.
simply statements about them.
Oh, definitely. I would encourage you to ask students to, what do you think this data means, or what was the source of the data? So that's another key element as well as for the data visualization process, is acquiring data. So we've talked about big data and being able to create visualizations. Well, you also have to understand from students especially, just because it's available on the internet does not necessarily mean that it is the best resource or the best source for the data. So actually, looking at reputable data sources. Who was this data? Who created this data, or who generated it? Is it available for all persons at any given time? And so looking at what's available, the source, that is very important as well, because as you know, garbage in, garbage out.
I appreciate you mentioning that as well, because I think that's so important, not only to think about the source of where that data is coming from, but I think also whether it's still accurate or relevant today, because I know we've in recent past looked at some data and we thought, well, that's 10 years old. I mean, that's not even representative of what we might be looking at today. But not if you hadn't seen that, I think it's lazy to make assumptions that, oh, well, this is what it is. It's just not. You've got to do that work. And
well, I will say, assumptions are good as long as you articulate them. So you can use that, what I'm going to call dated data, provided that you say that this data was from 10 years ago, and then you can build on that, so you can see maybe there's been some evolution or some changes since that particular data was acquired. And that's one of the things that I share with students, is to articulate what your assumptions are. And so sometimes students will say, well, I don't have any assumptions. And I always say, well, then you're not looking closely at the problem, because we all make assumptions. And so, but those assumptions helps to develop the end product, or it helps the person who looks at your end product to see your stream of thought. What were you thinking along those lines? And so those assumptions are very important. I just encourage students to articulate them, because it helps me to get a better idea of what were you thinking as you were creating this visualization, as opposed to what were you thinking? Oh my gosh.
that's very well said.
And so being able to see that, and having them to articulate their assumptions, and letting them know that it's okay to make those assumptions, provided that they have the evidence or the data to support them. So I think it's helpful.
I think so too, yeah.
So data visualization sits at the intersection of several different fields. So there's computer science, machine learning, math and statistics, of course, traditional research, traditional software, and subject matter knowledge and expertise. And so any of these areas that you see here use or utilize data visualization in some form or fashion. And so for those who are interested in learning data visualization, you don't have to be an expert in all of these fields, but data visualization will allow you to be able to communicate with others in these different fields, and it will allow you to be able to build those connections and understanding different processes in those particular fields as well. So I like to think of data visualization as a connector. So I'm going to stop sharing at this point, unless you want to see some current research. But I will say that I view myself as an agent for insight. So I talked about data visualization is about insight, not necessarily about pictures, but it's about gaining insight. And as an agent for insight, I am committed to broadening participation in visualization across different disciplines, for all of those who are interested in learning more about the process and learning more about how to actually engage with and utilize visualization as a skill and as a tool.
Perfect. Love that.
Oh, my
love the
goodness.
presentation. I love all the points.
Yes.
It's
I'm a little overwhelmed right now trying to think, but that was just awesome.